Good evening, everybody. My name is Ferhan Mazher, and the subject today we are studying is Pure Maths 1. We are solving its course book, and today we are working on the exercise 9B, and we are going to attempt the question number 14 of this exercise. A curve is such that d square y by dx square equals to 2x plus 8, given that the curve has a minimum point at 3 comma minus 49. Find the coordinates of the maximum point. Okay. Second derivative is given, so we can integrate it and we can find the first derivative, and from there I can find the equation of the curve, and then I can make the derivative equal to 0 to find the two stationary points. One stationary point is already given, and what we will do when we found the second one, then we can decide that's a maximum point or not. Okay, so this is exercise 9B. This is episode 6. The topic of this exercise is finding the constant of integration. Pure Maths 1, ASA Levels Maths 9709. It's paper 1. Okay, so question number 14, and here we go. So d square y by dx square is given 2x plus 8. It is given that the minimum point is at 3 comma minus 49. The maximum point we have to find out. So d square y by dx square is equal to 2x plus 8. So I will integrate both the sides. So when I will integrate both the sides, so d square y by dx square equals to dx is equals to integrate this side 2x plus 8 dx. So this will become dy by dx. Okay. So this side will become 2x square divided by 2 plus 8x plus c. So this is 2 and 2 cancel. So x square plus 8x plus c. Then because I know this is the stationary point, because it's a minimum point, it's the stationary point at x equals to 3, which is a stationary point, that the stationary point, you know, the dy by dx is 0. So I will put x equals to 3 in here and I will make it equals to 0. So 0 is equals to 3 square plus 8x plus c. So 0 will be equals to 9 plus 24 plus c. So c will be equals to minus 33. Once I know the c, this c value, now I can write dy by dx is equal to x square plus 8x minus 33. Now dy by, I will integrate it again because I want to find out the equation. So I will integrate both the sides. So I will have y here. Here you will have x cubed by 3 plus 8x squared by 2 minus 33x plus c. Now because I want to find out the other stationary point. Okay, so I know the dy by dx expression. The dy by dx expression is this, so I will make it equals to 0 because at the maximum point, which will be also a stationary point, the dy by dx will be 0. So from there I will find the other value of the x. So x square plus 8x minus 33 equals to 0. So x square plus 11. So I'm going to do the midterm breaking here. So x square plus 11x minus 3x minus 33 equals to 0. Take x common, so you will have x bracket x plus 11 minus, take 3 minus 3 common. So in the bracket you will have x plus 11 equals to 0. So you will have x plus 11 bracket common. In the other bracket you will have x minus 3. These two brackets, they are multiplying with each other. Their answer is 0. So either the first bracket is 0 or the second bracket is 0. So what I will do, I will make the first bracket equals to 0. So x plus 11 equals 0. So x will be equals to minus 11. X minus 3 is equals to 0. So x will be equals to 3. So this x equals to 3, that stationary point we already know. But x equals to minus 11, that is the next, the other stationary point. So I will take the second derivative to find out the nature at this point. So in the second derivative, which is given already, 2x plus 8, in the place of x I will put minus 11. So when I put a minus 11 there, so 2 into minus 11 plus 8, so that's minus 22 plus 8, so it's minus 14, which is a negative number. So which means that this point will be a maximum point. Now I want to find out this point. So first of all, the equation of the curve, which still has a c in it, I will put this first, the minimum point there to find out the value of the c. So in the place of x, I will put 3, and in the place of y I will put minus 49 into this equation. So I brought it here. So you will have minus 49 equals to 3 cubed divided by 3 plus 4x, 4 into 3 square minus 33 into 3 plus c. So you will have minus 49 plus equals to 9 plus 36 minus 99 plus c. So bring them to this side. So minus 49 minus 9 minus 36 plus 99 equals to c. So c will be equals to 5. So the equation of the curve will become y equals to x cubed divided by 3 plus 4x square minus 33x plus 5. So when the x will be minus 11, which will be a maximum point, so in this original equation, I will put x equals to minus 11 and I will try to find out the value of the y. So what will happen here? So y will be equals to, you see, minus 11 whole cube divided by 3 plus 4 into minus 11 whole square minus 33 into minus 11 plus 5. So that's minus 1331 divided by 3 plus 484 plus 363 plus 5, that is 408 whole 1 by 3. So that maximum point when x is equals to minus 11, the y value will be 408 1 by 3. So this is how you will do the question number 14 of the exercise 9b. The topic of the chapter 9 is integration, and the topic of the exercise 9b is finding the constant of integration. This is our 6th episode on this exercise. So let me show you the next question. The next question coming up on your screen is the question number 15. He says, a curve is such that the dy by dx is equals to 3 minus 2x and 1 comma 11 is a point on the curve. Find the equation of the curve, and the b part is a line with the gradient 1 by 5 is a normal to the curve at the point 4 comma 5. Find the equation of this normal. Okay, so there are two parts, a part and b part. The dy by dx is given, a point on the curve is also given. It's a very simple, straightforward question. So we will go to the next. So this is exercise 9b, and this is the episode 6 on this exercise. So we are on the question number 15. So the dy by dx is equals to 3 minus 2x. It is given. 1 comma 11 is a point on the curve. Their a part is find the equation of the curve. If you want to find out the equation of the curve, the dy by dx is given to you. So what we will do, dy by dx equals to 3 minus 2x. We will integrate both the sides. So integrate dy by dx into dx is equals to integrate 3 minus 2x dx. So this will become y. This will become 3x minus 2. The one power will be increased. So with the same power you will divide. 2x squared by 2 will be cancelled. So you will have so y is equals to, so you will have y equals to 3x minus x square plus c. So we know that the curve is passing through this point 1 comma 11. So in the place of x I will put 1, in the place of y I will put 11. So you will have 11 equals to 3 into 1 minus 2 by 2 into 1 square plus c. So this will be 11 equals to 3 minus 1 plus c. So c will be equals to 11 minus 3 plus 1. So c will be equals to 9. Now I know the equation of the curve. The equation of the curve will be y equals to 3x minus x square plus 9. So you can also write it like y equals to 9 plus 3x minus x square. So in the b part, he asked us that the gradient of the normal is 1 comma 5 and the normal is at a point of 4 comma 5. And they ask us to find the equation of the norm. It's very simple, straightforward question. So what we will do, we will try to find out the equation of that line which is normal. The formula is y minus y1 equals to m bracket x minus x1. So I will use this point and this gradient. So y minus 5 equals to 1 by 5 into x minus 4. So y minus 5 is equals to x by 5 minus 4 by 5. So y will be equals to x by 5 minus 4 by 5. This minus 5 will come here and it will become plus 5. So when you will do on your calculator minus 4 by 5 plus 5, that will be plus 21 by 5. So y will be equals to x by 5 plus 21 by 5. So if you multiply both the sides with the 5, you will have 5y equals to x plus 21. So this is the equation of the normal. So now we will go to the next question. And the next question showing up on your screen is the question number 16 from the exercise 9B from the course book of the Pure Maths 1. Uh, a curve is such that dy by dx is equals to 3 under root x minus 6 plus, and the point P, which is 1 comma 6, is a point on the curve. Find the coordinate of the curve, and the B part is find the coordinates of the stationary point on the curve and determine its nature. So this is question number 16, and we will attempt this question. The question number 16. So question number 16 is showing up on your screen. So they have given us dy by dx equals to 3 under root x minus 6. There is a point on the curve which is 1 comma 6. Their question is find the equation of the curve. So I will take dy by dx equals to 3 under root x minus 6. I will integrate both the sides. So here on this side, when I will integrate, you will get y. When on this side I will integrate, this is x raised to power 1 by 2. So 3 into x raised to power 1 by 2 plus 1. 1 by 2 plus 1 is 3 by 2. So with that same number, I will divide minus 6x plus c. Because so this will become 2 by 3 into x raised to power 3 by 2 minus 6x plus c. So 3 will be cancelled. You are left with the 2 into x raised to power 3 by 2 minus 6x plus c. So this is the equation for y for that curve. So we know that the curve is passing through this point, which is 1 comma 6. So in the place of the x, I will put 1, and in the place of the y, I will put 6 to find the value of the c. So you will have 6 equals to 2 into 1 raised to power 3 by 2 minus 6 into 1 plus c. So 6 will be equals to this one, anything raised to power 1 raised to power something. The answer is 1. So you will get 2 here minus 6 plus c. So c will be equals to 6 minus 2 plus 6. So that is c equals to 10. So that means the equation of the curve will become 2 into x raised to power 3 by 2 minus 6x plus 10. Okay, so this is how you find the equation of the curve. The next question is find the stationary point and find its nature. You know that at the stationary point, the dy by dx is 0. We already know dy by dx, so I will take it and I will make it equals to 0. So 3 under root x is equals to 6. So under root x will be equals to 6 by 3. So under root x will be equals to 2. So take square on both the sides. So you will have, when you square both the sides, you will have x equals to 4. So the stationary point is when the x is equals to 4. So y equals to 2x raised to power 3 by 2 minus 6x plus 10. So I can put this x value here, okay? And I can find the coordinates of this stationary point. The x and x we already know. We can also find the y coordinate. So 2 into 4 raised to power 3 by 2 minus 6 into 4 plus 10. So it will become 2 raised to power 4 minus 24 plus 10. So that's 16 minus 24 plus 10. That's 2. So the coordinate of that stationary point is 4 comma 2. Now I want to find out the nature of that stationary point, whether it's a maximum point or a minimum point. We know dy by dx equals to 3 under root x minus 6. Under root x means that x raised to power 1 by 2. I will derivate it, because to find the nature of that point, I need the second derivative. So this derivative, I will derivate it again. So d square y by dx square will be equals to, the power will come on the side. So 1 by 2 into 3 into x raised to power 1 by 2 minus 1 power. So minus 1 by 2 power is left. Minus 6 derivative is 0. So d square y by dx square will be equals to 3 divided by 2 under root x. So in this, I will put this x value to find out the nature of that point. So in the place of x, I will put 4. So 3 by 2. And in the denominator, we also have under root 4. So that is 3 divided by 4, which is a positive number. So if the second derivative at this x value is positive, that means that this is a minimum point. So the stationary point is 4 comma 2 and it is a minimum point. So this is how you will do the question number 16 of the exercise 9b. This is our sixth episode on this exercise, and we are trying to finish this exercise today. So the next question which we are going to practice in this video is the question number 17 from the exercise 9b. And you know, the topic of this chapter 9 is integration of the AS mathematics. And the topic of this exercise is finding the constant of integration. So let me show you the question number 17. So I hope you can see the question number 17 showing up on your screen. A curve is such that the d square y by dx square equals to 2 minus 12 by x cube. The curve has a stationary point at the p where x is equals to 1. Given that the curve passes through the point 2 comma 5, find the coordinates of the stationary point p and determine its nature. So this is the question number 17 and we want to solve it. So let me take it to you. So my dear students, the solution of the question number 17 is showing up on your screen. So d square y by dx square is given to us is equals to 2 minus 12 by x cube, a stationary point P where the x is equals to 1. We know the value of the x, okay? The curve passes through the comma 2 comma 5, okay? Another point is given. Coordinates of the P is question. Nature of the P is question, okay? So because the double derivative is given to us, d square y by dx square equals to 2 minus 12 by x cube. So I will integrate both the sides. So I will integrate this side and I will integrate this side. So when you integrate this side, you will get dy by dx equals to, this becomes 2x. This becomes, bring this x cube upstairs. So you see 2 minus 12x raised to power minus 3 dx. Okay, so when you integrate, this becomes 2x minus 12 come as it is. You add one power in this, so you will have x raised to power minus 2. With the same power you divide, okay? So you divide with the minus 2 and plus c. Minus minus will be cancelled, 2 6. Okay, so you will have dy by dx equals to 2x plus 6 by x square plus c. We know that when you put x equals to 1, it's a stationary point, and so at the stationary point the dy by dx is 0. So dy by dx, put x equals to 1 and make dy by dx equals to 0. So 0 equals to 2 into 1 plus 6 divided by 1 square plus c. So 0 equals to 2 plus 6 plus c. So c will be equals to minus 8. Now I got this c value. So dy by dx will be equals to 2x plus 6 divided by x square minus 8. So now I will integrate it again, okay? So dy by dx into dx equals to 2x plus 6x raised to power minus 2 minus 8 dx. So this will become 2x squared divided by 2 plus 6x minus 2 plus 1, that will give you minus 1. With the same number you will divide, minus 8x plus c, another c here. Okay, now I know, so let's simplify this. Y is equals to x squared minus 6 by x minus 8x plus c. And I know that the curve passes through this point, so x equals to 2, y equals to 5, because the curve passes through this point, and this is the equation of that curve. So in this equation of the curve, in the place of the y, I will put 5, and in the place of the x, I will put substitute 2. So you will have 5 equals to 2 square minus, I'm putting the x value here, 6 by 2 minus 8 into 2 plus c. So 5 will be equals to 4 minus 3 minus 16 plus c. So c will be equals to 5 minus 4 plus 3 plus 16. So c will be equals to 20. So that means that the y is equals to x squared minus 6 by x minus 8x plus 20. So I know that the here at the stationary point the x equals to 1, so I can find its y coordinate of the stationary point. So when the x equals to 1, the y will be 1 square minus 6 by 1 minus 8 into 1 plus 20 In this equation of the curve, in the place of x, I have substituted 1. So y will be equals to 1 minus 6 minus 8 plus 20. So y will be equal to 7. So the coordinates of the point P are 1 comma 7. Now they ask us to find the nature of this point also. To find the nature of the point, whether it's a maximum point or a minimum point, you have to put its x coordinate into the second derivative. We already know the expression for the second derivative, so I will take that expression and I will substitute in that second derivative's expression x with the 1. So 2 minus 12 divided by 1 cube, that will be give you 2 minus 12, and that will give you minus 10, which is a negative number, which means that this is a maximum point. When the second derivative's value becomes negative, that means that that point is a maximum point. So that means the point P, which is 1 comma 7 are its coordinates, is a maximum point. So my dear students, this is how you will do the question number 17 of the exercise 9b, and this is our 6th episode on this exercise. So let's move to the next question, and the next question we are going to solve is the last question of this exercise, and that is question number 18. So my dear students, question number 18 of the exercise 9b is showing up on your screen. He says that a curve is such that the dy by dx is equals to 2x minus 5, and the point P, which is 3 comma minus 4, is a point on the curve. The normal to the curve at the point P meets the curve again at the Q. Find the coin of the curve, find the coin of the normal to the point to the curve at the point P, find the coordinates of the Q. So this is question number 18. You can note it down. I'm going to show you the solution of this question. So exercise 9b, this is our episode number 6 on this exercise, and question number 18 is we are going to solve. So dy by dx is given, that is 2x minus 5, and a point on the curve 3 comma minus 4 is also given. We want to find out the equation of the curve. So I will integrate both the sides. So integrate dy by dx equals to integrate 2x minus 5 dx. Okay. This will become y. This will become 2x squared by 2 minus 5x plus c. Because this is the point on the curve, so in the place of the x I can put 3, and in the place of the y I can put minus 4. So minus 4 will be equals to 3 square minus 5x plus c. So minus 4 will be equals to 9 minus 15 plus c. So c will be equals to minus 4 minus 9 plus 15. C will be equals to 2. So the equation of the curve will become this x square minus 5x plus 2. The value of the c is plus 2. So this is how you will find the equation of the curve in the question number 18. Okay. Now we have to find out the equation of the normal at the P, which is 3 comma minus 4. So I know the x value here. I will put this x value in the dy by dx. That will give you the gradient of the tangent. The gradient of the normal then we can find at that point. So put x equals to 3 in this dy by dx. So 2 into 3 minus 5, so that's 6 minus 5. So the gradient of the tangent is 1. The gradient of the normal, because normal is perpendicular to the tangent, so its gradient will be the reciprocal of 1 and the sign change. So that will be minus 1 by m1. So that will be minus 1. Okay. Equation of the normal, I will use this point and this gradient and this point, and I will find the equation of the normal. You know, normal is a line, so its equation is y minus y1 equals to m bracket x minus x1. So in the place of y1 I will put minus 4, in the place of x1 I will put 3, and in the place of the m, the gradient of the normal, that I will put minus 1. So y minus minus 4 equals to minus 1 bracket x minus 3. So y plus 4 is equals to minus x plus 3. Y will be equals to minus x plus 3 minus 4. So y will be equals to minus x minus 1. Y plus x will be equals to minus 1. So this is the equation of that normal. Now, they want me to find out the coordinates of the point Q. and point Q is where the normal touch that curve again. The normal touch the curve at the point P and then again at the point Q. So they want me to find out the coordinates of that point Q. So I know the equation of the curve y is equals to x square minus 5x and plus 2. I know the equation of that normal, which is equals to y equals to minus x minus 1. I'm going to solve these two equations simultaneously. Okay, so here you have x square minus 5x plus 2 equals to minus x minus 1. I'm solving them I made them equals to each other. So x square minus 5x plus 2 plus 1 equals to 0. X square minus 4x plus 3 equals 0. I'm going to do the midterm breaking here. So x square minus 3x minus x plus 3 equals to 0. From the first two brackets, I will take, from the first two terms, I will take the x common. So bracket x minus 3. From the last two terms, I can take minus 1 common. So in the bracket, I will have x minus 3, bracket close equals 0. From this term and this term, I can take that bracket x minus 3 common. So in the other bracket, I will have x minus 1. So these two brackets are multiplying with each other and their product is equal to 0. That means either the first bracket is 0 or the second bracket is 0, or I will make both of them equals to 0. So x minus 3 equals to 0. So x will be equals to 3. X minus 1 equals to 0. X equals to 1. This point was already given to me. So I'm going to look, I'm going after this point, x equals to 1. So I will try to find out the y coordinate, because this lies on this curve. So I will take the equation of that curve, and in the place of x, I will put 1. So y will be equals to 1 square minus 5 into 1 plus 2. So y will be equals to 1 minus 5 plus 2. So y will be equals to minus 2. So the coordinates of that point Q, the second point where the normal touch that curve, is 1 comma minus 2. So my dear students, this is how you will do the question number 18. And by this question, we have reached the end of this exercise 9b. The topic of this exercise is finding the constant of integration. This is the course book of the Pure Maths 1. This is paper 1 of the AS and A levels mathematics 9709. This was our 6th episode on this exercise. The topic of this chapter is integration. Sir, my name is Ferhan Mazher and I'm from Sargodha, Pakistan. If you find this video useful, if you find this video helpful, please like this video, please subscribe my channel, please share the link of this video on your social media account, share the link of this video with those students who need this help in their AS mathematics. You see, your support, your like, your comment, and your sharing of this video is an appreciation for my work and is a support for my work. Your appreciation, your support, they both are very, very important for me. So I hope that this video will be helpful to you. So thank you very much, everyone, for watching this video and taking out time and preparing your AS Maths from my channel. So thank you very much. God bless you. Have a good night, sir.